which you are very used to. You only need to change the RPC URL and you will be deploying on Scroll. It works exactly, everything works exactly the same. Scroll is compatible at bytecode level. So the bytecode is exactly the same. Scroll the same EVM just as in Ethereum. In terms of the ecosystem as well, there are a lot of applications, like a very Ethereum native applications deployed on Scroll. We have Uniswap, Aave, Safe. We have Compound. In terms of developer tooling, we have Chainlink. And other oracles. We have the graph. So a lot of tools that you're used to. Of course, for the tool and the applications to be available on Scroll, they have to be deployed on Scroll. But it's very easy for application that was built on Ethereum to also support the Scroll, because it's pretty much the same. So if there is an application that is not yet on Scroll, just or a tool, just let us know or let them know that you want the application on Scroll, because it should be very easy to port. And it's a very growing ecosystem. Actually, these numbers are outdated now because Scroll has grown even more. So we're very happy. We're happy because Scroll is a very new project. It was launched on October last year, and it has been growing a lot. So we expect Scroll to keep growing. We're very happy about all the applications. Very Ethereum native applications that are deployed on Scroll, also Scroll native applications that were born on Scroll, which is super, super cool. We're very happy about both. And we just expected Scroll to continue growing, having more users, more applications, and just giving a new and better user experience for users used to the Ethereum ecosystem. Okay, so now why does Scroll exist, and what is the Scroll mission? So Scroll is targeting to solve the scalability issue that also you guys mentioned just now. So what is it? Okay, so I would like to start by bringing you this sentence. This is something that I took from the Ethereum website, ethereum.org. This is on the landing page from ethereum.org. You will see this, which reads, Ethereum is open to everyone, wherever you are in the world. All you need is the internet. Like this is the Ethereum mission. It's something very core, very fundamental for Ethereum, being available for everyone, not just for a few. We wanted decentralization to just reach everyone. Of course, there is a big problem, which is transaction fees, and they are so high. And this is a problem because this will leave behind everyone that is not able to pay those fees. So this is a big problem for Ethereum, something that needs to be solved. This is a problem because people who are not able to afford, they will be left behind, and also new use cases will be left behind because just being just too expensive. People wouldn't want to use it. So a few concepts that we need to understand is that Ethereum makes work, which is computation that is measured in gas. Basically, computation. The Ethereum is like a computer, like a machine that executes code, and all this code is stored in blocks, and all this work is stored in blocks, and the capacity for each block is limited. Because of course, if you make the block too big, it will centralize and no one will be able to run a node. But if you make it too small, the capacity is very limited. And when the capacity limit is reached, the one who pays the higher tip to the validator will be included first. So this is the concept of block space. If more people wants to use it, the more expensive it gets. The problem right now, well, the good thing, but also a problem, is that many people wants to use Ethereum at the same time. So it's so expensive right now. Okay, so now we're going to trilemma, as you guys were mentioned before. So in order to consider a blockchain like a good blockchain, it has to have three fundamental features: scalability, decentralization, and security. So what do we mean by each of one? Scalability is fast and cheap. Decentralization is giving the ability to anyone to send a transaction in a very easy way. So this is being able to run our own nodes without the need of a data center or something like that. And we also need high security. And the biggest blockchain security potential problem is the 51% attack. Well, in Ethereum, it's like the 66 or 33% attack. But in the end of the day, arguably the two most secure blockchains today are Bitcoin and Ethereum. But so in Bitcoin, the security gets measured in the amount of miners in the network. If you want to attack Bitcoin, you will need like a super huge computational power. And in terms of Ethereum, you will need an economic attack, which because Ethereum is proof of stake. So Bitcoin today is the most secure proof of work blockchain, and Ethereum is the most secure proof of stake system. But more important than that, Ethereum is the most secure smart contract platform because, of course, Bitcoin doesn't have smart contracts applications that allow it. So today, Ethereum is the most secure blockchain. Of course, the problem is that Ethereum and Bitcoin focus. So the trilemma is that if you focus in two of them, you might sacrifice the other one. So in terms of Ethereum and Bitcoin, they focus on decentralization and security, and they have sacrificed so far the scalability. And why did Ethereum and Bitcoin took this strategy? Personally, I think this was a good strategy because if we focus on decentralization and security, these are the new factors. Like if we focus on scalability too much, it's like we go back to Web 2. So we'll go back to Amazon Web Service with everything super cheap. We'll go back to Google Cloud, to Azure, but Bitcoin and Ethereum are very different. Decentralization and security is like the new thing. And that's why Ethereum and Bitcoin just focus on these two aspects first. Of course, this doesn't mean that security is just long forgotten, but it just means that they just put the fundamentals of decentralization and security, and then just little by little focus and balances into scalability. So I will mention before, Ethereum executes work, and this work is stored in blocks. And so the first idea about like scaling Ethereum was sharding. And when Ethereum was created with shards, like just scaling into shards in mind. So the idea is that if you have a lot of staking or hashing power, because Ethereum was doing mining back then, you can just divide the network in different pieces so you can have more optimized sections. So you can share some resource, but also just divide some resource to help scale the network. Of course, the problem is that when you divide the resource, the specific gets susceptible to attacks. So that's the problem. That's why Ethereum just say, okay, let's just forget about sharding. Well, the only thing that we did do was this tank sharding, but it's different because Now we're focusing on rollups. So rollups, the good thing about rollups is that everything on the rollup, everything on this layer 2s, all the security is inherited to Ethereum. So you're not dividing Ethereum and making it more fragile. You're just having all these rollups that all the transactions that happen on the rollup, everything is secure, like by Ethereum. So yeah, this is a more safe approach. And yeah, this is the path that Ethereum has taken. So yeah, so Vitalik wrote the rollup-centric roadmap, which is something that I think it makes a lot of sense. Not only because the two good things about rollups is that the two good things that one, every rollup inherits the security 100% from Ethereum. So that's super good. The other good thing is that every rollup can experiment with different technologies. So you know that we have optimistic rollups, we have CK rollups. For example, Scroll is using the CK EVM project for scaling. Polygon is using PIL, and CK Sync is using other systems. So everyone can focus with different stuff. And not only with different technologies, but also with different cultures. You may have found like different rollup with very different cultures. Like if you go to one ecosystem to the other, you will find that people hang in different places, and I think that's super interesting. And yeah, I think this is a super interesting approach. Of course, this is not perfect, and the problems with switching to rollups. The first one is that the sequencer, we're going to talk about the sequencer in a moment, needs to be decentralized. Right now, so far, we don't have a sequencer that is 100% decentralized. Does this mean that the rollups can steal your funds? No, that's not possible. But they can maybe censor you, or they could be a bug on the rollups, on the rollup contracts, or on the implementation on layer 2s. But yeah, we're going to talk about this and how is this being addressed by Scroll or in general by the ecosystem. And the other problem, of course, is the fragmentation of liquidity. Right now, we don't have actually a good user experience because you may have some funds on Optimism, and then some funds on Scroll, and then some funds on Mode, I don't know. And everything is so fragmented, and the user experience, especially if you're a new user, is not really. Can this be solved? Yes. We have maybe we can have shared sequencing that can help a lot of this. We can have an intense user experience that make everything easier and abstract it away to the user. We can have account abstraction to help stuff like this, and we can have account abstraction with Keystore, with something that Scroll is very focused on. We're not going to talk much about Keystore, but yeah, there is a lot of solution for this, but this is not the present. The current state of rollups, of course, is this fragmentation of liquidity, which is not a good experience for users. But yeah, but in general, I think the rollups is a way better manner to scale blockchains. And I think it's been proved that all the layer 2s have grown a lot in the recently, and I think they're going to continue to grow, and we'll be able to find ways of solving all the current issues that we have today. Okay, so why rollups? Of course, security, because everything is inherited by the security from Ethereum, and also we don't rely just in one technology. The technology from StarNet is very different from the technology from Scroll, which is very different from the technology from Arbitrum. So we don't have a single point of failure. We have diversity of technology. We have diversity of cultures also. So a lot of experiment, and this is something that we really like. Okay, but how does rollup work? How do we have this off-chain computation? that Ethereum verified and know that basically the layer 2 didn't cheat, didn't include a false transaction. So layer 2s are off-chain protocols, which means that they operate outside from Ethereum. They don't operate on Ethereum smart contracts, but outside of them. But despite that, everything that happens on layer 2 gets secured by layer 1. And so how does it work? So you have Ethereum computation. And for example, the first ideas that were implemented were the optimistic rollups. You have Optimism and Ethereum implemented, and they do fraud proof. So the fraud proof was the first implementation of a rollup, and you may have heard of them, is that you assume that everything is correct unless someone demonstrates and slash the bad actor for trying to insert an invalid transaction. This is super good, but there is a problem, is that you have to wait for finality time. You just have to give like a prudent time, like a very like enough time for someone to check if everything is correct. And if no one proved that something was incorrect, you can basically have the transactions sent as canonical and finalized on Ethereum and accepted on Ethereum layer 1. So they're super good. They help with scaling, but the problem is that the finality time right now goes around a week. Yeah, a week is the amount of time that we define as enough for someone to prove that a transaction was incorrect. Okay, so Scroll uses a different technology, of course. Scroll uses the ZK rollup technology, which uses the ZK EVM with validity proof. So what does this mean? Is that the Scroll doesn't have to wait all this time for someone. The Scroll never assumes that a transaction is incorrect. So when a transaction reaches layer 1, it gets verified. And yeah, you just have to wait for the time for Ethereum to accept the transaction. You don't have to wait a week. You have to wait only minutes to reach the finality time. So this is more safe and just more secure and faster finality time. So this is super good. Of course, it doesn't mean if you have used Arbitrum Optimism, it doesn't mean that if you make a swap on Uniswap, for example, that you have to wait a week, or you will have to wait minutes on Scroll. No, everything happens in seconds, but there's always a chance of reorg. The transactions just are rolled back on the chain if a transaction was found incorrect. The difference is that in optimistic rollups, that reorg possibility is in the terms of a week, and in a Scroll and all the ZK EVMs and all the ZK rollups is in terms of minutes. So yeah, that's a lot better. Okay, so how Scroll was born? How did this project start? And what technology is it using? So actually, Scroll is not the most of the code base from Scroll didn't originate on Scroll. They actually originate in the PSC, in the Privacy and Scaling Exploration organization. That is an organization from the Ethereum Foundation. So the story goes like this. So that the PSC, Privacy and Scaling Exploration, is always exploring the very futuristic ideas. So one of these like super crazy ideas that they were exploring is, what if we convert the Ethereum layer 1 into a ZK layer 1? So that's why they did the ZK EVM projects. And you can look at that on GitHub. The PSC ZK EVM project was this idea of turning Ethereum layer 1 into a ZK layer 1. So what Scroll did is that they forked the project, and they say, okay, just to put it one step ahead, closer to making that a reality, making just going a step forward to become a layer, a CK layer one. What we're going to do is just grab the same code base from the PSC and turn it into a rollup, turn it into layer two. So two things happen here. So one is that Scroll Scroll is helping Ethereum because the best way for scaling Ethereum right now is to make it the transaction cheaper and faster on a layer two. So Scroll is using this project to just scale Ethereum in a layer two. But also, Scroll is also proving that, so you have all this execution that is now being proved in production, in mainnet, because Scroll is on mainnet and people are using it. There is a lot of testing involved on that. So Scroll is showing that Ethereum in the future can become is one step forward to become a layer one. Of course, we're not there yet. There's a lot of things that need to be researched, not only technically, but also socially. There will be a lot of social, a lot of things that will need to be discussed for Ethereum to become a CK layer one. But Scroll is showing that it's in many ways, this is possible. Not in the whole implementation, but just specifically the execution. And so also Scroll now the biggest contributor to the CK EVM project. So now Scroll contributes more to this project because they have like a direct incentive to make this work. Now Scroll just finishes the execution part of the work from the PSC, and now Scroll is the biggest contributor to this project by far. So as you can see, like Scroll is not all the work that Scroll does not only helps Scroll by itself, it also helps Ethereum layer one. So this is good not only for the PSC, but also for not only for. It's not like, I think this is very symbiotic because Scroll is helping the Ethereum, the PSC code, but also works the other way around. Whatever, there's a lot of interest, not only by Scroll, but in general by the Ethereum community through snarks and zero knowledge help scaling Ethereum. So all this research that is being done is fully compatible with Scroll. So it's like, I think that's why I really like about Scroll, because this is very natural. I work at Scroll because I just really like Ethereum. I just really like the project. I really like the ideas. I really like the culture, and I really like the technology. And I feel like Scroll is helping all the technology. It's also like is an extension of Ethereum culture. So that's why I like Scroll. But at the same time, all the advancements from Ethereum help Scroll. So I think there's something very natural, and I think something very future-proof, because I do think that Ethereum is going to continue being better, and by proxy, Scroll is going to continue to improve too. Okay, now in a technical way, how does it work? Now we're going to deep dive and how Scroll works. So as you can see, you have the blocks on layer one on the top of Ethereum, and you have the blocks on layer two on Scroll. As you can see, you have more blocks on Scroll than on Ethereum because there is faster block time. So the first things that does Scroll is just bundles a lot of blocks and then just stores them on Ethereum. Actually, this graph is a little bit updated because, as you know, now Scroll stores everything on blobs. Now with tank charging, it doesn't store all the blocks on a block on Ethereum, but now on the blobs. But in general, it's the same process. Scroll bundles or groups a lot of blocks that it's called a rollup, and that just get bundled together and stored on Ethereum. why is this important? Why does you need to store all data on Ethereum? That's because you need to be able to read everything that happens from Ethereum if you want to force anything. So if the data is only on scroll, and you don't want that, because you don't have to trust scroll to use it. So you can force right now. That's not yet implemented, but that's going to be implemented in the future. That you will be able to force a transaction from Ethereum to scroll. And why it is important? Because you can bypass the whatever system that scroll used, and scroll will be forced to include your transactions. And you can only execute the transaction from layer 1 from Ethereum if you know all your data. So that's why scroll has to, if scroll wants to provide all the information to the user, that's why scroll stores all the information on Ethereum. Of course, this makes it more expensive, but yeah, scroll is not trying to sacrifice like any security part. So that's why scroll stores all the block data on Ethereum. And once all the block data is stored, scroll will generate ZK proofs and for all the transactions, and it will send a transaction to layer 1 to validate that all this block data was correct. And Ethereum would only accept the validity proof if it's cryptographically correct. So yeah. And as you can see at the bottom, there are a couple of steps done to reach finality. So the first one is pre-committed, when the transaction gets accepted on layer 2 on scroll, which is 1 or 2 seconds. So you make a swap on Uniswap, and the tokens will show up on your wallet just in a couple of seconds. And then a transaction gets committed. So all the data, when it gets committed, is all the data from the transaction was stored on Ethereum, and this is a couple of minutes. And then it gets finalized like 10 or 15 minutes later, when the ZK proofs were generated and verified